Hello everyone, my name is Hao Lin, and my research topic is Percolation theory, a new perspective of global connectivity. First one, I want to introduce the concept of percolation. Imagine that we have many sources of fire or smoke, or water, or many fissures on a stone. Think about this problem. If the number of sources increases, or the impact of each source expands, what will happen? We will see some big events, like we cannot cross the fire line, we cannot see anything through the smoke, the water will flow, the stone will be broken. Let's go to the random graph, and we focus on whether the impacts of the nodes can be connected, and the connections between the nodes can generate large-scale connected component finally. So in wireless communication, percolation theory can help us investigate such two impacts. First one, we focus on the impact of base stations on devices. And what we can do is to investigate the ability to generate large-scale continuous coverage for the mobile users or vehicles. And let's focus on the impacts of devices on each other, and what we can do is to capture the ability to generate remote multi-hop D2D communication. Based on these two events, and we can investigate more advanced topics about global connectivity. In the future, wireless communication should be more sustainable, cooperative, flexible, stable, and global. So we can think about these topics. First one, we can use the percolation theory to investigate the ability to realize D2D communication between power IoT devices. Because we have a large number of IoT devices, and we want then build a large-scale links. And also we can use percolation theory to investigate how infrastructure sharing improve the performance on the vehicles and the users. Third, in the future, we will investigate how apps to assist the gateways and the remote areas, like the rural areas and island maritime areas, to connect them and provide continuous coverage for users. Finally, for the whole Earth, we will think about how LEO satellite connect the whole world, like use the LEO satellite to realize global size applications. So using the percolation theory, we can capture the probability of generating large-scale remote D2D or the generated large-scale continuous coverage. And we can also use it to reduce the density or the number of nodes we need. It's not just applied on terrestrial, we can also use it in non-terrestrial networks and to reduce the future cost of HAPS and LEO satellites. Finally, percolation theory provides us a virtual KPI, which is percolation probability, to capture the global connectivity. Also, it's also a virtual tool to reduce the CapEx and OpEx due to the deployment of wireless networks. That's all. Thank you very much.